So like I said, I just found out that I can use my phone as a webcam. So it'll be sitting right there. One of these seats will be designated for that. There's a seat here. You're welcome to sit here. Not this one. That would be weird. Okay, we'll have it. All right, we'll see. So yeah, so I will be recording the class so that I did it last semester with my other course, and they found that it was good to like reference things that maybe you missed. Maybe you wanted to revisit an example that we worked out in class. So it seemed to be very helpful. I took a little survey, so I want to keep doing it again. And so let's see. It's not here. Let me go here fast. So can I have you guys take a quick, we're gonna do like a little icebreaker-ish thing, but it's not really like an icebreaker. Can I have you guys go on your devices? And if you don't have a phone to do that, you can go to, what was it? Let me see, does it say here? No, let me see, it'll be menti.com. So menti.com, and then the code that you'll put is 4229, 4224, 9181. Let me put the QR code back. Okay. So just a quick little 2-question survey. You can either go to menti.com, put this code, or just use the QR code here. Okay, go for it. Way. Hopefully it works. It's bright enough. Is it bright enough? You're in the back. Does it work? All right. Perfect. So it'll just say the first question, just what are 2 words when you think math, like what are the 2 feelings, 2 words that you're going to associate with mathematics? All right, so as you're doing that, let's see. Share my screen on Zoom. Okay. That way you guys kind of see, get a feel for the class and your classmates. You guys will be working together a lot this semester. I like to think of my teaching style like I'm like a coach, we're on a team, exams are like game day, you know, something serious, but definitely we're all the team, we're all in this together. You have similar experiences, you all have strengths, so I want you to, you know, work and help each other out. I will be directing you to all the resources that we have on campus. And then if you've had, you know, like negative experiences with math, hopefully I change that a little bit and give you some positive experiences. Doesn't mean I'll be easy. It just means that hopefully I can use some positive experiences. I'll be easy when I can, but with the next questions, I'll talk about the rest of what I'm about to say. So let's see, the biggest ones we have here are fun, interesting, hard. I think those are the 3 biggest ones, and useful. We got excited, challenging. Then we have confusion. We do some scared, some anxious. Sweet, I love this. I love doing word clouds. It's good. It's a good way to kind of get the feeling of the class. Cool. I usually don't see that one that big, so that's good. It's cool. All right, let's see. We got 36 of you. I think that's all of you guys. So yes, like I said, hopefully, you know, if you've had some negative experiences with math, and this is your first college math class, hopefully I can kind of change the narrative a little bit, give you some positive experiences, while at the same time kind of preparing you mathematically, challenging you a bit, but also supporting you a lot. Okay. Okay. Next thing I want you to do. Let's see. Let me see if it works. There we go. All right. So now on your phones, you should see new questions pop up. Again, if you showed up late, go to menti.com and enter this code here. Come on in. Let's see, I don't know what I have on seats. All right. And on your phone, if you can go to menti.com, and then this is the code that we're using to go into the survey. All right, let's see. So you're taking pre-calculus. I wanted to see how many of you are here to prepare yourself for calculus. Looks like a good chunk of you guys. Some of you guys maybe not sure, or you don't need it for your calculus class. I'm confident in my algebra skills. We got about 3.4 average out of 5, and I'm confident in my trig skills. So we have just a little bit more confidence in trig than algebra. Who took math 121? You're not saying, okay. So in that class, they definitely focus a lot on the trig, right? But you did some algebra, but you didn't do like a lot of algebra with like exponential functions and logs and all that stuff. Right? So that's kind of what this class is also going to prepare you with. And so, yeah, so definitely, these are the two biggest things. Whenever I teach calculus, guys, the reason students don't pass or just find it really challenging is not because of the content of calculus. It's because of these two skills. It's because the algebra is very intense and the trigonometry, like, it's also very intense. Because you're answering like other higher level questions that require you to just know the all these trig facts and identities and things like that. Okay. So I will be focusing on the trig in this class, not all of the trig that you learned in your previous trig class, but the main trig components that you need for calc. And from what I found, usually students really need to make sure they're prepared for. And the same thing with algebra. Okay. All right, sick. All right, so let me turn this off. I think, let's see, I'm gonna stop sharing this. All right, guys, so let me go to Canvas real quick. This class has everything organized on Canvas, so I want to make sure you guys are familiar with that. Exit here. I will put this guy to the side since I'm done with it. All right, so this is our Canvas course. Who still doesn't have access to Canvas? Perfect. All right. All right, so let me go on student view. Should I go on student view? No, not just yet. I guess I'll go for it now, just so you guys can see what you'll see. Okay, so who's using Canvas for the first time? Oh, okay. All right, so I'm not going to assume you guys remember everything, but this is the front page of our Canvas course. As you saw on my welcome letter, I'm a big Legend of Zelda fan. Got my tat right here with some link doing this sword spin. But yeah, so the class will be, give us some kind of flavor to a game. We are pretending we're helping Link and Zelda, and you're going to come across bosses, which are exams. And our final will be that nasty Ganon. And throughout, the reason I'm doing this is because when you play video games, you lose a lot. Okay, and you have to learn from the mistakes and you have to change your strategies a lot. Okay. And that's similar to a STEM course. There is a lot of mistakes, there is a lot of failure, but you got to make sure you change it up and keep powering through to see how you can achieve that goal that you're trying to achieve. Right? You didn't answer the question correctly. All right, what happened? What did I do differently? Let me change my strategy. So that's the parallels I view with a STEM course and a game. And so I just wanted to add a little flavor. Underneath this is the main topic calendar for the semester. So if you're curious or you're trying to plan out your semester because maybe you have a really big important trip, make sure you look at what's being covered. It tells you when the exam's happening. Here's exam 1. So Zelda's like super like, oh my God. She's super crying there. So yeah, so here's everything we're doing organized down below. You guys have your spring break. Exam 3, and then we keep going. We're doing some trig here in the middle of it. Exam 4. Oh, it's not showing this one. It's a little too dark to see in the projector. So I just wanted to show you that's what this is showing you, okay? Yeah, right? Come on, Breath of the Wild. Like, you haven't played it? That's too bad. I'm just playing. We have your announcements here every Monday. I'm gonna post some announcements. Make sure you read those. It tells you what you need to do when exams are coming up. If exams are coming up, I'll tell you about the study guides and other things to prepare you for the exam. So make sure you look at those announcements. If you go to modules, this is kind of the way it's broken down, organized in terms of assignments. So as I said in my welcome email, you have your orientation module, which I need you to read through. And then there's an orientation quiz that's due tonight, okay? I think you have like 3 attempts. It's pretty simple. It's not like hardcore. I'm not trying to like, I'm not trying to be a punk. I just want to make sure that you know some important things about the class. And then after that, this is the main structure that you guys will see. So at the top of each week, you'll see week videos and handouts. So as you're noticing, I'm recording the class. So after it's recorded, after we're done with class, it starts loading on the Zoom cloud. And then once it's ready, then I'll post a video on this guy right here, under where it says Monday's class notes. And I have the PDF of my notes. So next to the video, I'll also have the PDF. Okay. And then same thing for Wednesday. And then down here are any handouts that are important for that week. Cool. Okay. Let me go back to the modules. Right now, we're going to talk later on. We're going to talk about WebAssign. Here's the key that you guys will need. But the main structure will be that you'll have homework, online homework that you'll be doing on WebAssign. That'll be here on this module. And something called a problem set. I'll talk about that once we get to the syllabus. Cool? And then that will be the theme for each week. It's like the videos will be on top, the WebAssign homework, and the problem sets. And any other little Canvas assignments that are there for that week. So let me see, make sure I talk about that real quick. If you need to email me, you probably already know this, but you can email me here through Canvas. And I have Canvas forward every Canvas email to my inbox. So I always see when you guys email me. I don't have to go on Canvas to see it. So in my opinion, I think this is the best way to contact me. I think it's Canvas. That's why I respond the fastest. Okay. Through Canvas, you'll access everything. So you don't have to go to another website. You can just go through Canvas. So for our online homework, you'll be going through here. You'll click this and it'll direct you to WebAssign. Okay. Let's see. Okay. Here's the syllabus. Let me talk about that real quick. And then throughout this whole thing, if you have questions, just go ahead and I'll stop. All right. So I click the syllabus tab. Here gives me my assignments, the breakdown of my grades. And then here is the PDF of my syllabus. So let me click that. So you can access the syllabus through here, okay? But because it's a little small, let me download it. So that way I can see the whole thing. Let's download it, open it up. Damn it, no, I don't want to open it through the stupid browser. Hold on, here we go. Okay, make sure I share that on Zoom. All right, guys, so here's my syllabus. It has the class meetings. I will be having office hours every day except Friday from 11 to 12. Okay. Not in my office, but in something called the Math and Engineering Student Center, which I think I'm trying to do it so that we have the last 10 minutes of class to go walk over there. Okay, so you guys can see where it's at. I love holding my office hours there. I'll talk more about that once we do that. Scroll down. Let me go make this a little smaller. Here are my class principles. Number 1 is I'm aware of the cultural and academic challenges associated to mathematics. Know that no matter your background, you're in this class because you're capable of doing the work and learning the material. Okay. throughout the whole time I've been teaching, students only aren't able to pass the class because of life. Life gets in the way, and it doesn't let you study that long or just spend that much of your focus on school. Okay. But in terms of intelligence, all that, I fully believe that you guys have the capability of doing it. And I'm also here to help you out as much as I can. Okay. Academically and like just culturally as well. Okay. Number 2 is make this class a positive math experience by collaborating with your peers and learning from one another. So there are going to be a lot of problems where I have you guys work in groups. I'm not going to group you up, but I'm not going to move you, but you guys will be grouped up with the people next to you. Okay. And there's passive learning, which is just you listening to me. And then there's engaging active learning, where it's like you need to explain to someone what the domain of the function is, and you're like, oh crap, I know how to write it, but I don't really know why I wrote it this way or why this is the answer. So it helps you acquire a higher level of understanding, which is why I like doing that. And it's also a little bit more engaging. And when you transfer to a university, it's a survival skill to know how to just like work with someone else. And also learning who you can work with and who you can't work with. That's also a good survival skill. Yeah. Number 3, if you let me, I will help you become a stronger student by supporting you and challenging you at the same time. Right? So there'll be, some homework problems that will be a little bit challenging, but I'm here to help you out, and the Student Center is definitely also there to help you out. All right, we're in this together, as I said. Let's see. I'm going to go over the main parts because the syllabus is a little dense. Here's a course breakdown. So your web assigned grade is 25%. Participation will be like little bit sprinkled Canvas assignments. Like there's gonna be one where I want you guys to interview a tutor. I forgot the other ones, but there are a few Canvas assignments. And at the beginning of class, some days, not every day, I'll have a warm-up. Well, I'll have you guys it's a very open-ended, not too crazy of a problem, and you'll just work with your classmates. Then I'll collect that warm-up. That will also come. Okay. Web assigned is all online homework. You can do it online. Problem sets, you could also do it online, but it's going to be written, and you're going to write out your solutions, and you're going to post them on Canvas, because I want to be able to see your written work. Because on web assignment, I just see your answer, right? Like what you submitted, but I don't get to see your written work. Okay. And so those would usually be like 2 or 3 problems. They won't be that long. Or sorry, I won't give you that many problems. Okay. But I do want to get a taste of your style, the organization of your algebra. And so it's great. It's going to be great. I'll talk about that later. It's going to be graded more on like, not just like the math that you did, but like the organization of your work, the notation. Are you using correct notation? That's so important, especially if you go to calculus. How you understand things in your own words. So it's very kind of holistically versus just did the app that you use to solve this do it correctly, right? Like that, whatever. I want to see that you're understanding it, because for the exams, they're in person and you guys have to write all your solutions, right? And so I want to make sure that I can assess that to better support you. That way you don't come to the exam, you're like, now I'm grading on your work, but you never saw my work. You guys get me? Okay. And so there'll be 4 tests. So all the exams are worth 40% of your grade, and then the final will be worth 20% of it. We'll talk more about that as we get there. For web assign, I drop your lowest 2 assignments. Because life, right? Sometimes it's like it's gonna, something happened. So it'll get dropped. And then anything that's submitted on Canvas, you can turn it in late, but you get a penalty of 5% per day late. Yeah. So if you're a day late, you still get 95% on it. Questions so far? Okay. Let's see. Your web assign, let's talk about just the bolded parts. Monday's material, so whatever we learn today on Monday, that homework on web assignment is due Friday. And whatever we learn on Wednesday, that homework will be due on Sunday. Okay? The problem sets of the week will cover the material for Monday and Wednesday. It'll have 1 or 2 questions from Monday and Wednesday's material. That will be due Monday of the following week. Okay? All right, just making sure. For your problem sets, I'll grade it. If you fail it or you don't do that well on it, you can always come to my student office hours and we can correct it together, and then I'll change the grade so that you get a 70%. All right. Again, I really want to make sure that your work and the way you're answering problems, I could tell that you're understanding your own work and what the problem asks you to do. All right. Let's see, I'll talk more about that. Here are your exams. They're in person. You'll be allowed to pay 1 page of a notebook size page of notes front and back. Okay, for every exam. Yep. All right. I'll give you guys study guides and all that good stuff. If you can't take the test, it's happened many times. You wake up, you freaking tires flat or something's happening to the car, and you can't get to class, just email me by that day, and then we'll work out a makeup exam. Here's the information if you're interested in our DSS services. I'm going to have someone later on come speak to us about that. So she'll give you guys more information. I think those are the main things. Here, make sure you take a look at these deadlines for when you can drop a class. Those are important. Take a look at those. The September one's hella wrong. That should be February. Sorry, I'll change that. Thank you. You know what? Can I do that right now? Hold on. Let me just do it live. Oh, damn it. You know what? It'll be bolded. That's fine. Yeah, I'll update it on there. All right, guys, and then we'll end it with the cheating stuff. Don't cheat. We'll get to it if it gets to it, okay? But basically, don't cheat. I'm pretty good at catching folks. There's an advantage to having a young instructor and a disadvantage. The advantage is they can do a little bit more tech stuff. And the disadvantage is I'm very knowledgeable on the tech stuff, okay? All right, let's see. Okay, I'll end it with that. You could browse the syllabus a little bit more. What I want us to do right now is I want to make sure your Canvas is set up. So if you have something with you to access Canvas, maybe like a computer or a tablet. If you don't, it's fine. It'll be recorded. You could do it later on. Oops, yeah. Okay. So what I would like you guys to do is if you click, there's a little symbol there, a little logo, a little icon of your account. If you can click, make sure it's recording. Hold on, I gotta make sure this is being recorded. Yeah, okay. If you can click that button there, if you click profile, you can edit your name and your preferred pronouns. So if I go here, it'll allow me to edit my profile here. Okay, so that's how you are able to change those features. Let me double check that it does that. Hold on. Yeah, here we go. So that's if you click profile. If you click, what is it? Settings. If you click settings, what you can do is you can designate an email on Canvas so that it can forward to you emails and announcements. But Canvas needs to know which email to do that to. So on settings, you would click settings and then you would click add email. And then you could put the email that you wanted to. If you're using a Gmail or whatever other email you use, you would put that here and then click register email. It's just because I have a lot of students who are like, oh, I didn't get the Canvas message. So this will help. So you'll add your email here. Then once you've added the email that you want Canvas to forward things to, you go to notifications. Next these things. And you can, the way this works is that this is the, you're going to be, I think you guys have like at insight.4cd. So it'll have your insight email, and then it'll have the new email that you added. Okay. If you use a Canvas app, that's what this is for. These are the notifications for the Canvas app. Okay. So once I want to make sure that you guys choose is go to the one that says announcement. And then either if you use the app, you click it and you can put notify immediately. And if you want the announcements to be forwarded to your email, you can also do that here by clicking the little bell here. Okay. But one of these, one of your either your personal email or your app, the Canvas app, please have that announcement so that it forwards it to you, so that you have access to it. So announcement is one of them. What's the other one? Grading. Anytime I grade any of your assignments, please have it notify you so that you know immediately when I've given you a grade for an assignment. So there's grading, and then there's comments, submission comment. So whenever I comment on anything on your work, you go here and have it if you want. That one is if you want. Okay, but that way you'll know that I left you a comment. Those are the three that I want to make sure that you guys allow. Your announcements, grading, and then comment, at least for this semester, for the class. Okay. Questions? Yes. I went right here where it shows your, maybe you'll show a picture of your face or just like an icon, and then you go to notifications. But to add your email, you go to settings first to add your email. Okay. Okay, so there was that. Now, this next one's optional, but it's good to know. If you want your DVC emails to be forwarded to your personal email, if you want that, I'm going to show you how to do that. And you can only do this on a web browser, only on a web browser, not on the phone or tablet. Okay, sorry, on a computer. So the way you have Canvas emails forwarded to your personal email is you go to Insight, log into Insight here, click it, and then it'll ask you to put your username and password. But at some point, access your DVC email. And then once you're here, let's see, hopefully this shows up. Yeah, there'll be the little gear here on the top right there. Boop, boop, boop. You'll click that little gear and search the settings and put forwarding. You click that, and then if you want, you go to enable forwarding, and then you put your personal email right there. And that way, DVC emails will be forwarded to your Gmail, whatever it is, okay? All right, I wanted to show you guys how to do that, because that's a very important thing to do, especially for like financial aid emails and all that good stuff, or just important announcements that DVC has for you. All right. Go back here real quick. For class. Okay. So now I want you guys to set up your website. You don't have to pay right now. Okay. I'm gonna have you guys just do it so that you already get those 2 weeks free, and then deal with the money later. Okay. So let me go on student view. So the way you're gonna do this is you have to go to your first homework assignment. You'll see your homework assignments here in the front page. They're located right here, the web assigned ones. You can go to the modules as well. I'm going to go through the modules path. You're going to click homework 1. That's your web assigned homework. So you would click this bad boy. Then it's going to direct you to web assign. So I'm going to click load homework 1. It's gonna direct me to WebAssign. On the phone, I'm not sure how it'll look. Give it a minute. Basically, it's connecting your Canvas account with WebAssign so that they talk to each other. Hopefully something like this shows up. And it'll tell you Math 191, Spring 23, Section 1228. That's the section of pre-calculus. All right, let me stop there. That showed up? It didn't show that up? It might take a while to load. Okay, just stay there for a minute, guys. Let's see. This is still loading. So some people, it's taking them to the login screen. Is that what it's doing? Okay, that's so weird. Let me see, you're on that one. Let me do this one and then I'll do the other. Okay. So if you're on this one, what you're gonna do, if you already went to the bookstore and you got an access code from the bookstore, then you would click enter your access code here. Okay, but I'm assuming you don't, and I just want to give you guys that free access for 2 weeks. So I'll click continue. Okay. If you buy it online, the access code, it's $87. But if you buy it at the bookstore, the same access code, it's $66.66. So it's cheaper at the bookstore. Oh, I already did my free access, but under here, you see where it says temporary access period for this product has expired. That's because I did that last week. Okay, or like a month ago. But down here, there should be a button that says temporary access. Is that true? Has expired. It says that for you too? Yeah. That's my life. Okay. All right, hold on. I'm gonna have to go ultra mode right now. Give me 1 second. I gotta get out of this thing. That's why I wanted to do this in class, because I'm like, yo, those emails are gonna go wild. Let me see. Hold on. Give me 1 second. There's basically the publishing company and the college have like an agreement. So it's like, let's make it cheaper and then we buy more from the bookstore. Yeah.
Do you have the course key?
Yes, the course key. If you're already there, let me show you. The course key is right here on Canvas. Actually, let me write it down. Let's write it down real quick. You're already there. So web assign class, or is it called course key, class key? I forgot which one. So it's DVC lowercase 15856742. That will connect you to this class. But let me just check something. I think the reason it's saying it's expired is because I was playing around with WebAssign and I put that the class started like January 9th, which is incorrect, obviously, but give me 1 second. Load it. Oh, I have an idea. See if I can do this in less than 2 minutes. Perfect. Okay. Let's see. Course settings. Oh, yeah, there it is. Okay.
course starts today. Hold on. Yes. Oh, no, I wanted to start today, dude. All right, hold on, guys. So annoying. Okay. All right, it's not letting me change the day the course starts. It's saying it starts January 9th, which today is the second week, which is why it's saying it's expired. One or more something. Oh. Hold on. Sorry. Hold up. What's today? The 23rd? Seventh. Let me try one more time. If not, we'll do this the second day so that I can figure this out. Or one or more assignments are scheduled to the section. You cannot change the date visible to students. Okay, I'm gonna have to call them then and do it later. Okay, that's okay. We'll do this on Wednesday, okay? No, I can't have that happen. Hold on. Sorry, I have to delete your homework. Yeah, that's fine. Let me try one more time. Okay, now let me do it. Now. We'll do this on Wednesday, okay? It's gonna take too long. Sorry. You guys are just been chilling here. Actually, we're gonna take a break in a bit. What time is it? All right, not yet. So, first day, man, it has to happen, right? Tech. At least the projector was working. All right, hold on. That was called homework one. Homework one. Section 1.1, A-3. Okay. And then words. I basically have to reassign your homework super fast. Give me 1 second. Almost 3, 7, 13. Okay. 3, 7, 13, 20, 37, 45, 51. And then the appendix 4. Okay. All right. All right, now I gotta schedule it. Give me 1 quick second. Relax, do a little shoulder roll while you wait. Almost done. Okay, it's due this Friday. Okay, perfect. Go here. This one, this one. Contents. All right, guys, so go to module 1 again. Okay. Oh, God, I have to go super fast. Sorry. Let's try this again. Let me go to student view. Go to module 1. Click the homework. Go here. And let's see if it works this time. Okay. So you would go continue. And of course, something went wrong. Can you guys do it? Click continue, see what happens. Did it do that? Did it do that too? It went to the sign-in page? Okay. Okay, if you go to the sign-in page, here, let's do that. Let's go to DVC. I'm a little nervous about the sign-in page because it needs to connect to your WebAssign. Yes. I know, but I needed to connect to your Canvas because the grades that you submit there automatically submit to let's see, what's an alternative? Let me just think real quick. Okay. Fuck it. I'm gonna have to do it manually. You got the temp access button? Okay. Okay. So I mean, if the original path I was taking should work now, okay, you go temporary access. If it's giving you the login screen, let me help you during the break. Let me see what we can do. Okay. Wow, that was crazy fast. Okay. Perfect. 1:30. I was gonna do a break. So let's take a little 10-minute break. Okay. Let me help out folks with the tech stuff and we'll resume at 1:40. If you, the restrooms, if you walk out this way, they're all the way on that side. Let me pause the recording. And then let me go around and help. All right. All right. Good stuff. Good stuff now. Right. So we're going to start from the very beginning. Section 1.1, and then the big stuff is going to be in what's called the appendix 3. Okay, we're just going to call it A3. And what we're going to talk about, something called real and complex numbers. I wanted to start the class off with all the types of numbers that you guys are going to be using in the class and like how to like compare them with one another, what they look like, the notation, all that good stuff. Okay, so up to now, you've done a whole bunch of, you've messed around with a whole bunch of different types of numbers, okay? The notation and how you write them is important, and what they're called is also very important. So we're going to start with the first numbers that you probably learned. This is a symbol that represents that set of numbers called natural numbers. And what's the first number that usually you think babies learn? There's 1 and then more than 1. Okay, conceptually, they don't know yet 2 and 3. They just know there's 1, something isolated and something that has friends with it. So there's 1, 2, 3, 4, and so on. Those are what's called the natural numbers. You start with 1. And then we have something called whole numbers. that has like a fancy little W like this. Like that. So if you see this symbol, that symbol is these numbers that we're about to write. So for many years, people were using 1, 2, 3, 4. And when there was nothing there was no number that was used for that. It was just, there's nothing there. Okay. But different parts of the world, different civilizations realized that it's helpful to have a conceptual representation of the number 0. So then they added 0 to the mix. And that's pretty much the only number that's different. Okay. And then with these whole numbers, then people started adding those numbers. So if I add 2 whole numbers, I get another whole number. 2 plus 1,000, 1,002, that's a whole number. But then they started subtracting these numbers, and that was not giving them a number that lived in this list. So like 4 minus 3, there was no number in this set that was representing that result. So then they expanded it to, what did they add it to the mix? Negatives. And when you add negatives to this list of numbers, that list is what we call integers. And the symbol for it is this fancy Z. Yeah, right? That way when you're like reading something or you're looking at a video or something and they show these symbols, I don't want you to get thrown off. That's what they're talking about. And yes, you guys are right. So we have 0, 1, 2, and all the positives. But now we added the negatives to the mix. And all the ones that keep going that way. And so then we're good for a while. We can add integers and subtract integers and multiply integers, and we still get an integer, right? But then when you start dividing integers, that's where it got weird. Like if I was to divide 10 by 2, what's 10 divided by 2? That's an integer. But then if I was to divide 7 by 2, I wasn't getting a number that lived in this list anymore. Yeah, and that would be different from these. That's not part of these numbers, the 3.5. So then we had to add even more numbers to the mix. Fractions came here. And so these are called rationals. And that symbol is this fancy Q with a little strike on it. And the Q stands for the quotient, the division of 2 things. And this one, instead of listing it, I'm going to write more of a definition. So we're going to say rational numbers are numbers that can be expressed as a ratio A over B of 2 integers. 2 integers A and B, where B cannot be the integer 0. You can't divide by 0. So it's a mouthful of a definition. So it's fractions, but the things on top and the bottom, the numerator, the denominator, can only be these kinds of numbers, integers. Okay, that's what makes something irrational. Wait, this is in blue. So equivalently, another way to look at rationals, when you divide 2 numbers, you guys get decimals, right? Like you guys said 3.5. It's a number that can be expressed, I'm going to write a little below, sorry, as a decimal as a what's called terminating. Can't spell terminating. terminating or repeating decimal, and I'll explain what that means. So for example, is the number 5, okay, I'll wait for you guys to finish writing. All right. So equivalently, a number that can be expressed as a terminating or repeating decimal. Now I'll explain what that means. So is 5 a rational number? According to this definition. So turn to someone next to you real quick, and then just tell them if you think it's irrational. If you do think it's irrational, explain why you think it's irrational. If it's not, give them your short little reasoning why. Okay. So just do a quick little pulse. Get little acquainted here. Let's see. So all right, let's see. We're on Zoom. I'd have a little poll, but I don't. Okay, let's see. The definition says that a rational is a number that can be expressed as a ratio, A over B, of 2 integers, A and B. So is there a way to write 5 as a fraction of two integers?
5/1.
5/1. So because 5 equals 5/1, by definition, it's an integer. Okay? Questions? Okay. Now it says equivalently, I can also write it as a decimal that either terminates or repeats. What is terminating? Let's see. So is there a way to write 5 as a decimal? 5.0. I can write 5 as 5.0. Those are both equal values. And I only need 1 digit for the decimal. I don't need to keep writing a bunch of stuff. This is what's called a terminating decimal. It just stops with the digits, the decimal digits. Or you can think of it as 5.0000, and it just keeps going. You can think of it like that as well. So you can think of it as a terminating decimal, or this is what repeats. These digits just infinitely keep repeating. So that's what's called a repeating decimal. All of these things in this class are equal to each other, and they're all telling you the same thing, that it's the value 5. Okay? Let's look at another one. Let's look at -7/10. That one, I'm writing it as a ratio of 2 integers. You can think of it as -7/10. That's equal to -7/10. Or you can think of it as 7 over -10. All of these 3 are the same thing. They're both equal. Okay? As a decimal, what is 7/10 as a decimal? I can write it as -0.7. What place is it in? 7/10. Okay? So I can think of it as a terminating decimal, or I can think of it as 0.7, and then what would be to the right of it? Just a bunch of zeros after that. I can think of it like that. Okay? So these are all the different ways to write the same number, and that's why I'm going over this, because it's like, you're gonna, depending on the problem, you're gonna write it in different ways. All right, then we have one more. 13, what did I make here? 13/18. That's a ratio of two integers, 13 and 18. Someone help me out here with a calculator. What is that as a decimal? Put that in the calc real quick. Curious to see what it shows you on the calculator.
0.722.
0.7222222, and it just keeps going on. That. Okay. And so this is it a terminating decimal? No, because that two keeps going. But maybe in another class you learned that you can write this as 7.2 with a bar on top. Correct. And you got to be very careful when you put this bar. Because if you put the bar and you get lazy and you do that, that's a different number. That's 0.727272727272. You want to tell the reader only the two is repeating. So then that bar only goes above the two. Okay? All right. How's that? Does that kind of help you guys with the definition here a little bit more? Any questions? Okay. Also, very important, that negative, okay? It could be on the top or it could be on the bottom. That's going to matter when we start doing a whole bunch of weird fractions with like algebra. And then sometimes you'll be like, wait, do I put the negative on the top or do I put the negative on the bottom? It turns out either. It's just where is it going to be easier to manipulate or cancel things? Okay. All right. So then we had rationals from our list. And for a moment in time, people thought that was it. We've expanded all types of numbers because every other number can be written as a fraction of that. Okay. And you probably heard of the Pythagorean theorem. So there was a mathematician called Pythagoras. Pythagoras had a whole school to train folks to be mathematicians. And Pythagoras said, that's it. Every number can be written as a fraction. Okay. In the real world. And then a student came up and said, well, what about the square root of 2? Well, they didn't know the square root of 2 at that time. What they were saying is, if I have a square of length 1 here and length 1 here, the student, through all the math that they were learning, realized I can't express this diagonal as a rational. I can't seem to do it with everything I'm learning. Now we know that turns out to be the square root of 2. But then Pythagoras was like pissed because, kind of contradicting the whole, his beliefs, I guess. And the rumor is that they drowned him, okay? Because he was like kind of contradicting the grand teacher, I guess. And if you look it up, there's all these different rumors of how they did that, but it's a little dark. Sorry. But I was just telling you, like, that people were hella passionate about what they're studying, right? But it turns out the student was right. It was impossible to write this quantity as a fraction of two numbers. And so then they had to expand the list. And so that's what we're going to call irrationals. Irrational number. I don't think there's a fancy symbol for that one. And so the definition of this is any number that is not rational, meaning you can't express it as a fraction of two integers. That is not rational. And so if we look at the blue part, it says any number that can be expressed as a terminating or repeating decimal. So what do you guys think would be the opposite of that? A decimal that terminates or repeats. What would be like the counter of that? That it doesn't terminate or it doesn't keep repeating over and over and over. So what would that have to look like? What do you guys think? Doesn't terminate. So what does that part mean?
Fixed number.
Well, the terminating means that there was like a finite number of digits that you would use. So if it doesn't terminate, what do you guys think that would look like?
I think infinite.
Infinite, just keeps going. That's right. And it's also non-repeating. So it's infinite like this one, but it just can't repeat the digits, right? No repetition can happen. So you're saying pi. Pi, if you guys played with it, it's a number 3.1415, blah, blah, blah. It never stops so it doesn't terminate, but there's also no pattern to the digits. Nothing repeats in pi. It's just always random digits. Okay? And so equivalently, with my blue marker. And so equivalently, it's a number. How do I write it? That can be expressed as a decimal that doesn't terminate or repeat. And so, yes, some of the examples that you guys listed. I said square root of 2 was one of them, pi was one of them. What's another, what, you guys remember maybe another irrational number that you encountered?
Anything over 0.
Anything, you mean like as a fraction over 0? Is that what you meant?
Over 0.
Well, there's 5. Oh, anything over 0.
Yeah.
So anything over 0, because of this definition, you see this definition right here?
Yeah.
It says a over b of 2 integers, a and b, where b is not 0.
Yeah.
So it turns out that anything over 0 is not even part of this list. That's undefined.
Okay.
Yeah.
Isn't there one with like 13 or something?
There could be one with 13, but I guess it's another like kind of like pi. E, it's another fancy schmancy letter. That's part of it. That E stands for something else.
Oh,
Yeah. This E represents an irrational number.
So what about like prime numbers that don't like square root?
And then square, yeah, so square root of 2 is one of them, square root of 3 is one of them,
7?
square root of 7, I don't know if it has to be prime, like square root of 9 is also irrational, 9 is not prime. So,
It's like 13.
so it turns out that, let's do this, let's generalize it. Square root of n, where n is not a perfect square.
Square root of 9 is square root.
Oh, yeah, this is good. That's a perfect square. Square root of 15. 15 is not prime, but the square root of 15 is going to be irrational. And so as long as n is not a perfect square, then it's going to be irrational. Okay. Square root of 4 is 4 a perfect square. So that's why it's not irrational. It's actually going to be square root of 4 is 2, and 2 can be written as
the regular number.
2 over 1, so it's a rational, right? Let's see, these here are about 1.41421 ... Pi is about 3.1415 ... And then E is about 2.71828 ... And what this means is that these digits, guys, never repeat. There's never any repetition. You guys heard of Pi Day? So on March 14th, I'm going to show you how your birthday lives in pi and where it lives in pi. Okay, we'll do a little activity. Because any sequence of numbers should be able to show up in the digits of pi because it's just all random. Yeah, question.
Are imaginary numbers irrational, or I feel like you couldn't express it with decimals?
Well, exactly. Yeah. So we have rationals, which can be expressed as decimals that either terminate or repeat. And then we have irrationals that do the opposite. And so, yeah.
Isn't real numbers a thing, and wouldn't that just be natural numbers?
That was where I was going next. Yeah. So then when you put these two together, you put rationals and irrationals, we get what we're going to call real numbers. And that one is a little fancy R also with a little dash on it. And so this is what did I write here? Any number that can be expressed as a decimal. And so equivalently, as you mentioned, this is all rational and irrational. I'm not exactly sure why they're called real numbers. I think it's because in the real world, we use real numbers to measure things. Okay. Someone mentioned imaginary numbers. We'll get there a little bit later, but we're good with this list. And then we were able to solve a whole bunch of math problems with this list. But then there were some math problems that we couldn't solve. I'll get to that later. Okay. So right now we're going to stick with real numbers. We'll stop here for a bit. So we have this big old list of numbers that you guys are going to practice, like simplifying, and you got to remember how to add square roots and stuff, how to like simplify those, all that really intense algebra stuff with these guys. But I also need you guys to remember how to compare these numbers with one another. How can I tell one real number is bigger than another real number? Okay, that's going to be very important when we get to like functions and domains and all that. So to help us visualize, God, I can't spell today, sorry. To help us visualize real numbers, we use a number line. We use a number line. I'll just say that. We use a number line. And let's remember what that looks like. Nice little number line. What's in the smack middle of it? 0, whatever middle means here. And then we have the integers 1, 2, 3, and so on. And then we have -1, -2, -3. So what I would like you guys to do with your calculator and the help of your classmates, I want you guys to estimate. So anytime I want you guys to do something, it'll say practice. So I want you guys on this number line to estimate where 17 over 18 goes, where -7/10 goes, square root of 2, and e. Okay. These are all real numbers, so they can all be expressed as decimals, right? So these two are what kind of numbers? Irrational, and then these two are rationals, but real numbers are both, right? So the easiest way to determine where they lie with respect to one another is to express them as decimals. And that will help you figure out where they are in comparison to one another and on the number line. So let me have you do that real quick. Let me see, can you guys read that? Yeah. And maybe just put like a dot, plot a point, and then label it so that you know where it's at.
If you want, you can do it all on the same number line. You don't have to do different number lines. All right, so if you're not done, just do a quick check-in with the same groups that you did the other discussion with. Just take a look at your guys' work real quick. Discuss your, how you figured it out. So that you were finished. So let me have you put the number root 2 on my number. Blue and black. And then I'll pick someone. Yes. All right, let me have you do the negative 7 minutes. And then someone think about it. Put here, around here. How they say that was E, right?
No, you told me to do it too.
Okay.
See Davis is. I heard
Oh,
bad raps.
yeah. Thank you, thank you.
What was right there?
All right, perfect. Thank you, thank you. All right, let's see.
Yeah, Davis is not.
All right, so let's see, 17, 18. What was the decimal that you guys got for that? You wrote it as a decimal, what did you get? 0.94. Okay, we got negative 7/10. I think that one we did earlier, right? 0.7. Root 2 was this guy over here. Yeah, that's about 1.41-ish. And then E is about, is that 2.718? Okay, around there. Okay, so let's see, we got 7/10. It's close to -1, but it's not exactly -1, so it should be right there. And we got 17/18, which is 0.94. It's also very close to +1. Root 2 is 1.4. So it's almost halfway between 2 and 3, right? Oh, wait, I'm tripping. 1.4.
Oh, I did that one.
Okay. So that one should actually be kind of where this is located, but between 1 and 2. So notice that this one is bigger than the number 1, but less than the number 2. So actually this bad boy should be around right here. Okay. All right, and then we got E, right? E is bigger than 2, but less than 3, and a little bigger than 2.5. So it should be somewhere here. Perfect. So the homework will have you do a little bit of that. Okay. It'll have you place it. All right. So here's where you're kind of ordering the way your real numbers look like on a number line. You need to know stuff like this because it's going to ask you about later on. You're going to use graphs, and you're going to have to look at the x-axis, and you're going to have to kind of estimate numbers and kind of get a feel for these things. Maybe you plug in a number to a function, and the answer was 17/18. So you need to know where that is in relationship to the other numbers. Then we have comparing numbers. I think those came up. I'll leave your work right there. And so in this one, I guess the easiest way, I'll just say easiest way to compare real numbers
is to express them as decimals. And compare, how did I say it here? Their decimal digits. I guess alphabetically, and you'll see what I mean by that. So you just write them as decimal numbers, and then you just kind of compare alphabetically which one's bigger than the other by looking at their decimals. So let me give you guys some examples. I'll take it back here. Let's look at examples. So let's see, it says determine whether, I'm kind of writing it the way the homework does it, okay? Determine whether the following is true or false. And so let's say on the homework, you see this right here. Problem 1 says 1/2 is greater than 55 hundredths. The second one says 13/14 is less than 15/16. Okay. And so you want to see if it's true or false. And so the easiest way to tell is by writing these real numbers as in their decimal form. So what's 1/2 as a decimal? 0.5. What's 55 hundredths? 0.55. Now, see how this one has 2 decimal digits? Exactly. What'd you say? You add a 0 to this one so that it also has 2 decimal digits. Because since it's terminating, that means the rest of it is just 0, right? So by writing it this way, and what I mean by alphabetically is that notice that they both have a 5 in the 10th spot, but this has a 5 in the 100th spot, but this has a 0. So which one's actually bigger? 55 over 100. That's actually a bigger number. So this is false. 1/2 is not greater than 5,500. Okay. 13/14. What's that as a decimal? Help me out. 9285. What about 15/16? 97. 9375. 9375. So again, I compare alphabetically, digit by digit. They both have a 9, but this one has a 3 in the second decimal place, which is bigger than the 2. So then this number won't be bigger. So is that true?
Yes.
Yeah, so this is true. Okay. All right, I have 2 that I want you guys to try now. Just to do a quick little check. I'm going to write this 0.3 repeating, less than or equal to 4/12. And then the other one is 3√3, or 3 times the square root of 3 is greater than or equal to 26/5. Let me have you guys see if what's written here is true or false. Say. And same thing, just check with your classmates.
Yeah. It's true. How are you doing? It's my. It's like right there. Yeah, I'm 24. No, I'm 24 years old. Yeah. Like, I'm just.
Okay, let's see. What is this, what does this thing mean here as a decimal? 333, and it just keeps going. What about 412? Same thing, right? 3333, and this keeps repeating. So is this true?
Yes.
Is it less than it? But it's equal to it. And so remember, this means it's either less than it or it's equal to it. If one of those is true, then it works and it's true. Okay, it's true because it's equal to it, and that's what the little bar on the bottom says. Help me out here. What's 3 root 3 as a decimal? 5.1. Say it again.
9615.
5 and
Continuous.
the 5 continues.
No, like it just there's a lot more.
Oh, there's hella more stuff.
Yeah.
Okay. Okay. And then what about this guy here?
5.2.
5.2, just 5.2?
Yeah.
Oh, sad. Okay. So let's see. And then here, I guess, let's see. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Which one's bigger?
2607.
This bad boy, because in the 10th digit, the 2 is bigger than the 1. That's the alphabetical part. Okay. So this is bigger than that. So is it true? Is it true that 3 root 3 is greater than this number? Is it equal to it? So it's not true. It's false.
Isn't it? I mean, if you were to round the 5.2,
Yeah, no,
something.
exactly. If you round it, they're pretty much the same. But numerically, like if you don't round it, in reality, would they be right on top of each other in a number line, or would the other one be just a little bit behind it? See it? Yeah. And so yeah, so this is actually true. It's greater than. Oh, sorry, it's false. JK. You guys are awake. All right, say. Okay, so one thing to do is this right here, is comparing. Then there's going to be another very important notation called interval notation. Let's do that, and then we'll take a break. Okay? Let's do that real quick. That one is super important. If you get to calculus and your interval notation's rusty, it's going to be a hard class. So we got to make sure we really understand all the notation behind this. All right, interval notation. Let's do this one and then we'll take a break. All right, so what this helps us with is to express an infinite set of real numbers in comparison to other numbers we use something called interval notation. And there's some symbols that we need to talk about. One is you'll either use parentheses to say you're approaching that number, but you just don't include it. So when you use a parenthesis, what this will do is that it'll exclude numbers. I'll show you guys when we do it. We just have this for notes. So parentheses exclude numbers, and then square brackets include the numbers. You're gonna include those guys. And so let's jump into an example to see how that looks like. I'm gonna have you guys try some. And here's a good time where you want to make sure you ask questions or ask your classmates questions. Okay, so let's see. So I want to be able to express all real numbers. All real numbers x such that we got 3.2. We got x in between 3.2 and 5, but I'm going to write the inequality like this. Whenever you guys read inequalities that have a variable in it, start by reading it at the variable. Okay, so the way you want to read this is you would want to say x is what in comparison to this number? How would you say that? X is what? X is greater than or equal to negative 3.2, or x is less than 5. Okay. Sorry, yeah, less than 5. So let's see. On a number line, let's see what that looks like. Here's 0. Here's negative 3.2, and let's say here's positive 5. WebAssign, you know, in your past math class, you probably put like open circle or closed circle. WebAssign has you do it a little different because it's going to have you use this notation. Okay. So I want to include numbers, all the numbers that are greater than negative 3.2. So that's to the right of 3.2, right? That's to this side. But it could also be equal to negative 3.2. So because it could be equal to it, what you're going to do, and you want greater than, I'm going to put a square bracket, but I'm going to face it so that it's pointing that way to the right. Okay. So this, by putting the square bracket facing opening in this direction, it's saying you can include negative 3.2, but also something to the right of 3.2 because it'll be great. And it also must be less than 5. I can't include numbers like 6, 7, 7.2. It has to be less than 5, but can it include the 5? So what do you think we're going to use? We're going to use a parenthesis. But because you want it to be less than 5, the parenthesis is going to face this direction. Okay, yeah, question.
Is X the representation of real numbers?
Yes, what this is saying here is that I want to think about an X as any possible real number, as long as it's in between these two in this manner, correct? And that's why it's all these guys in between. And so I think then it also has to put a line like that. Okay. Why does it have you do that? Because now in interval notation, the way you write this set of numbers is you write what's the smallest real number that you can that this considers. What's the smallest one? So negative 3.2. Do you include it?
Yes.
Yes. So then you put a square bracket like this. And then you're going to put a comma, and then you're going to say, what's the biggest positive? Sorry, what's the biggest real number that you can include? Sorry. Yeah. Let me say it again. What's the biggest real number, but you may or may not include it? 5. Is it included? No. Okay. And so this notation, 1, you always have to go in increasing order. So it should always go on the number line in increasing order like this. Okay. Second, there's always a comma in between. The number on the left, or the thing that you put on the left, is like the lower bound. And whatever you put on the right is like the upper bound. It's just sometimes you do include them, sometimes you do not. Question.
Can you refresh my mind, like opening close? The circle.
Yeah, so like in a past math class, you would have done this number line. You would have written it like you include the negative 3.2 and you exclude the 5. So you would have done it like that in a previous math class. That's another way they did it. But WebAssign has you do it this way so that you understand the notation with interval notation,
And then when we do it on your test and all that stuff.
just like that. Yeah. All right, so this would be the answer of that. Okay? Questions? All right, let's see. I can tell some folks do have questions, but let's see. Let's do one more and then I'll have you guys work some out. And then the questions will pop up. That's the benefit of not teaching on Zoom, I can tell. All right, example number 2. This one's a little nastier. Let me stick with my color coordination here. Example 2. All real numbers x such that I'm just going to write it before I read it. 5, then we have the inequality, then x, or, and then we have x. Just write it first. All right. So on WebAssign, you're going to go on the number line. You always want to go in increasing order. I see the number 5, and I see the number 8. Okay. How are you reading this part right here?
X is higher than 5.
You want to be careful how you read it. Because if you read it, 5 is greater than x, by saying the word greater, your brain thinks greater, so it's going to go this way. But that's incorrect, because you want to read it by the variable first. It's really x is less than 5. So it's really all numbers that are less than 5. All real numbers that are less than 5. So that's why it's important to read it as this here. It's really just x is greater than 5. I kind of swapped it. Okay. Oh, goddamn. X is less than 5. X is less than 5. Okay, these are the same thing. This is how you write it. Okay, do I include the 5? No. So which way is my parentheses facing? To the left or to the right? To the left, yeah. And then everything less than 5, right? Okay. Then it says, or x is greater than or equal to. So which one do we use? Square bracket, because it could be equal to it. It can include it. Which way is it facing? To the left or to the right? To the right, because x is greater. And on the right side, you have things that are greater than. So then it goes this way. Okay. And so do you guys see how here we were doing everything in between these two numbers versus here it's like we're not including the things in between those two numbers. It's actually the opposite. Okay. So see this or right here? Whenever you guys see the or, when you're writing these things, this is going to use something called the union symbol. With the letter U, big old like letter U like that. And I'll show you where that comes in. So when you come across something like this, you take it at one interval at a time. So let's focus on this one first. You focus only on this one. What's the smallest number? What's the smallest real number that this is trying to tell you? Is there a smallest real number? No, right? It just keeps going and getting more and more negative. So because there is no smallest real number, we're going to put a negative infinity to say that. There is no smallest real number. It just keeps going to infinity. And put this in your notes. You never include infinities because they're not a number. They're just like a concept to telling you that it keeps going. So you always use for negative infinity or positive infinity. So if you're using an infinity symbol, you never put a square bracket. You always put a parenthesis. That's my lower bound, which really there isn't. Then I put a comma. Then now I kind of talk about my bounds, my upper bound. On this part only, guys, what's the upper bound? What's the biggest that you can get to?
5, 5.
A 5, but is it included?
No.
No. So then you put 5 with
Yeah.
parentheses, not a bracket, because in the bracket would include the 5. Okay? Okay, so you deal with this one at a time. Now we have this other interval. I'm gonna deal with that one now. Now just focus on this interval. What's the smallest number that you can get to? Is it included?
Yes.
Yes, so then we're gonna put a square bracket, comma, my upper bound. What's the biggest number that it gets to? There isn't one, so we put infinity. And I can include infinity, parentheses. So that's how you're gonna do this. If you have it split up, you take it at one interval at a time. Then I have 2 that I have to consider. So in math, when we see or, there's this symbol, big as U. Okay? And the way you read this is you would say all real numbers from negative infinity to 5, or from 8 to infinity. So it's kind of the way you're reading it. Okay?
Is the big N and? Is that what the? you see other-
If you see the other one, yeah, if you see this one, that one can be and, or it can be intersection. Like where they both agree with one another. Yeah. But normally, in this class and in calculus, this is the main one that you use. You rarely will see this. Yeah, but that's a good point. I'll leave that there.
Where did that one show up?
This one shows up. If, like, let's say you're working on a problem and let's say you're dealing with 2 functions, and one function has a domain, or sorry, one function, you plug in whatever function is. You plug in numbers that are greater than or equal to negative 3.2, but then in a different function, maybe you can only plug in numbers that are less than 5. So if you try to see where they both functions kind of agree on, that would be the intersection of these 2.
Like the middle of the Venn diagram kind of thing?
Yeah, it's exactly the middle of a Venn diagram, which is the intersection of the 2 things. Okay, let me give you guys 3 problems, and then you've earned yourself a break. I'll leave these 2 so you can reference it. Doing good, you're doing good. I know that some of these symbols might bring back some math trauma.
Yes.
It's all good. We're all here to help each other out. Okay, so practice. So express in interval notation and on a number line, just the way we do these. Okay, so I'm gonna write 1, 2, 3. I'm just gonna write it so that I don't read it. I want you to practice reading it. We got 3 x and 11 halves. X. Three. And then here I got x is in relation to 11 halves, or 7. All right. Let me have you guys try these 3. For each, make a number line and denote it the way we've been denoting it here. And then I'll walk around, please ask questions.
Don't forget your hundreds of books for this class.
Every right. You see how I put the blue line right here? Try to just like bold it with yours and your paper so I can see where you're putting them. Does anybody know where the other attendance sheet is? Does anyone need to fill it out? Then you guys in the back, right? You guys need to fill it out. All right, stop real quick, what you're doing, and just check in with one another. Just make sure that you're using the same station.
Is number 2 infinity? Infinity, right? Okay, okay, I didn't remember this one. Right, it's like, for what was it? Three and that's hard. I didn't not personally. 3 years.
You have your questions, put your hand up.
I did like. 3 years. They both happened. And then I don't know. And then so. I can focus on school and then. 2022, I door light. I did civil engineering. I did like all the engineering courses in my. I did like basic level like.
Keep checking with each other. I'm gonna write up the solution up here while you're doing that.
So I couldn't achieve the goal R very high. So it was exactly when.
Keep checking, keep checking. Let's see, I got 3.
Are you sure that is?
7. Hopefully you have something like this. Checking, keep checking. So I was discussing with someone, the reason you don't include infinity is because think of this, what it should really say is that it excludes real numbers or it includes real numbers. And infinity is not a real number, so you can't include it. Question?
So negative infinity doesn't say negative numbers, but anything going down.
It means it just keeps decreasing, yes. The values just keep decreasing and decreasing, which eventually take you to the negative side of it. Correct. Let's see here. Here's one thing I want to mention where you gotta be very careful, okay? I'm gonna rewrite this problem. And kind of explain real quick a common mistake. If I wrote it this way, is it different or is it the same? Let's see, x is greater than 3, so it's greater than 3, and x is exactly. And so here's where here you got to be careful though, okay? If you accidentally write this, that's wrong. Okay? It's including it, yes, and it's well, one, it's not even, it's just the format. This is what I meant by you want to make sure that your intervals are in increasing order. Is 11 halves bigger or smaller than 3? Bigger. That's not an increasing order. See, and that's where you can get all this stuff and stuff. So whatever numbers that you put here, make sure they're in increasing order, which is why I was having you guys practice comparing numbers, because that's important.
Will we always do it in this order, or do we have to move this around?
You might have to move it around. Right now, no, but later on, yeah. Yeah, later on. Like you'll be solving inequality equations and inequalities and all that stuff. And then things like that show. Okay, let's take a break. Let's come back at 3:56. Oh shit, 2:56. Class will be over by then. Yeah. Take a little 10-minute break. And we're gonna do some good algebra when you guys come back. Resume.
For number 2, if
Yeah.
it's like less than or less than, or if it had an equal sign, would it be, if it be negative?
Okay, so the way it was. So if you want, maybe just email me right now. This is my email right here. Pause my recording. Hold on, guys. All right, algebra of real numbers. This part here is very crucial. So it's important. It's important in this class. Or let's say it's important to know that sometimes operations on numbers produce different types of numbers, produce different types of numbers. And let me show you what I mean. You've learned all kinds of operations, addition, subtraction, square rooting, cube rooting, taking things to the 5th power, 8th power, things like that. And let me show you what I mean by that. Let's go right here. So like, let's say at some point down the line, we're doing all this other stuff, but you need to simplify this expression here. 3√5 plus 7√5 to the power of 2. And that needs to be simplified. Because in reality, this is a decimal number. Okay, it's a real number. But we just got to simplify it a little bit. You could put this in your calculator and it'll give you a decimal number, but sometimes the decimal number won't be, it'll be irrational. So it'll have all these decimals after it. And then you'll have to estimate it or approximate it. That's called the approximated value. But sometimes on the homework, it'll say, give the exact value. That means you don't want to write it as a decimal. You want to write it as how it looks. So for example, 3√5, you could put that in the calculator and you can approximate it to a decimal. But the exact value is 3√5. Okay? So we want to figure out what the exact value is of this number. So you gotta be careful with the operations here. PEMDAS screens here, right? PEMDAS. Do I deal with the exponent first and take both things to the second power? Or what else do I do first? Parentheses, which means I have to do what? You can expand it if these were variables, like 3x plus 7x, you could do that. But if you had 3x, actually, now that I said that, and 7x, what can you do with that? You would add them because they're like terms, right? And when you add them, what is it that you're really adding? What two numbers are you really adding? The 3 and the 7. So the way you deal with this algebraically, you deal with these irrationals algebraically as well. Which means when I add 3√5 with 7√5, I'm really just adding what? 3 and 7 to give you 10√5. And I'm squaring that because I'm dealing with the parentheses first. I'm adding inside first. You don't do 10 and then add the 5 with the 5 to get 10. You wouldn't do that. Okay? And that's okay if you thought that. That's fine. That's what we're going over this. These I forgot the name, radical expressions. This symbol here is called the radical symbol, the square root symbol in this case. You leave those alone and you only add what's in front of it. Okay? From here, though, this means that you're multiplying what with itself? You're only the √5? The 10 and the 5. So what this means is that you're doing 10√5 times 10√5. Squaring it means you're multiplying with itself. It will, but let's see why. Correct, yeah. But here's where I want to get at. When you add these expressions, you leave the 5s alone inside the square root. You only add the numbers outside. That's true when you're adding or subtracting. But when you're multiplying irrational numbers like this, you actually do have to deal with the √5. Okay? And in this case, you end up multiplying the 10 with the 10. So what happens is like you're doing 10 times 10 in one side of, like on your brain, but then you're also going to do √5 times the square root of 5. So with multiplication, you do actually multiply them together. Okay? 10 times 10? 100. When you have square root numbers or square root expressions, and they're both under the same square root symbol, you guys remember what happens? You put them both under the square root and then multiply them together. So it becomes 5 times 5, but now under one square root, which in this case is 25. And now, as you were saying, you get rid of the square root. But why did we get rid of the square root? Because the square root of 25 is 5.
Wouldn't it work if it wasn't a perfect square too? If it was √7?
If this was,
Or like, I guess, yeah, if you multiply it by itself, it's always going to be perfect.
if you multiply with itself, it'll always be a perfect square. Yeah, but if it was something like this, then you would have ended up with square root of 35. And then in that case, you couldn't have square rooted that.
Just leave it there.
You would just leave it. So if you keep going, now how I have the 100. How do I write this, Matt? Like, what do I write? This is the part where it's function. Times 5 times 5. Okay, so you can write it like this, or you can write it like this. But it's important that you understand that the 10 is multiplying this thing right here. So that really is 500. So if you put this on the calculator, it'll just give you 500. But it's the manipulation that you gotta get comfortable with. Okay? Photo math just will give you that, but all these other things, but I need to see you you need to do this because later on you have variables and you have to do it with variables. Okay? Now, what did I mean by this comment here? Well, you have 5√5 is irrational, 5√5 is irrational. And when you're adding two irrational numbers, think about what that means. You have decimal numbers with some weird ass decimals, right? It's infinite and they're just like random. But somehow when you add these two irrational numbers and you square them, it turns into a rational number, a perfect 500, which is kind of a little bit crazy, but I just wanted to, the point, that's what this means right here. Sometimes you have certain types of numbers, you do these operations, and then it produces a different type of number. So you'll do a little bit of this on WebAssign. And then the last thing I wanted to mention was complex interest before we end class here. Yeah, I don't think we're gonna have time for the students here. We'll do that on Wednesday. Okay. So we have our real numbers that we've been dealing with, and so far that's been like, we felt like that was the final solution set of numbers. Like, everything is good with those real numbers. So with real numbers, we come across issues when squaring. And let me show you what I mean. So let's say you're trying to solve for x, and you're trying to solve this equation here. Okay. And remember that meant that you're looking for a real number that when you plug inside here, satisfies the equation. Okay, if you plug it in. And so we're like, okay, I need to plug in a real number that when I square it and I add a 1 to it, will give me 0. And so that's where it's a little funky. If you try doing algebra, maybe you want to get the x squared by itself. So how would I move the 1 to the other side? You subtract the 1. And so then you end up with square root of -1. And then algebraically, how have you learned to get rid of the square? Square root. But here's where the issue comes up. If you put square root of -1 on your calculator, it'll say error, okay? And it's saying error because if I square -1, what's -1 times -1? 1. And 1 plus 1 is not 0. So it's basically saying that there is no real number that has this property. You can't do it. But mathematicians came across this and they were like, you know what? Oh God, I can't stand not having a solution to such a basic equation. So we need to expand our numbers. We're not done expanding. And so we have to create a different type of number, just the way we created decimals and we created pi and all that stuff. And so to get a solution to this equation, how do I say this? To create a solution to it, we created the number I to be this number, square root of -1. And where we wanted to have a property that when I square it, it gives me -1, so that when I add it to +1, it cancels out. Okay. So this is a completely different type of number. and it cannot be expressed with decimals. Okay? So it's not a real number. Okay? So we're getting a different type of number here. But if I had I, let's say, whatever the hell that thing is, and I added it with another I, algebraically, what do you think we would get if I added I? You would get 2i. And what if I added another I to it? 3i. And you can also subtract, right? So then you would also get like negative 3i or negative 2i. And so when adding or subtracting these numbers, we get a new set called imaginary number. And basically, this is a set of, you got like negative 2i, negative I, 0 still in the mix. I, 2i, and so on. I guess technically 0 should not be there since it's a real number. Yeah, that. And it turns out that now that I have this other infinite set of numbers, I can write square roots of negatives using these new type of numbers. And so, for example, in your homework, you'll be asked to express as an imaginary number. Let me show you what I mean. So let's say you got the square root of -4 or the square root of -7. Let's see how we're going to do that. Square root of -4, if you put that in your calculator, it'll say undefined because that is not a real number. Okay. But with this funky, weird imaginary numbers, you can think of -4 as 4 times -1. Okay. And you see how we split up, how when you have two numbers multiplying inside the square root, you can split them up like this as individual square roots. We're going to try doing that with this one. So I would split it up as the square root of 4 and the square root of -1. What's the square root of 4? 2, because now it's the square root of +4. But what did we say the square root of -1 is? We're calling that I. So in reality, this number right here, 2i, is also equivalently negative square root of -4. And the same thing can be done with this guy, except we don't have a perfect square. I could think of it as 7 times -1 and split it up as √7, root -1. And how would I write that one? This guy would be 7, correct? Yep. But this one, can we get rid of the square root? No, right? Because it wasn't a perfect square like this one. So in that case, this stays square root 7, and make sure the I is outside of the square root. Okay? I'm gonna squeeze the whole 3 minutes, guys. Sorry. The weather sign shit threw off my schedule. Okay. So these are completely different types of numbers that your calculator can't compute. So then what we do is we get these imaginary numbers, and then we get real numbers, and then we add them together, and that gives us what's called a complex number. And that's our final list of numbers for a calculus class. There's more, okay? But that's the final list of numbers for a calculus class. Has a fancy C, and they're called complex numbers. And so this is any number of the form A plus BI, where A and B are real numbers. So this A and B are real numbers, it's just the BI makes it imaginary. Okay, so I'm gonna leave one last problem and then we're done. And it comes across when you're dealing with the quadratic formula. Okay, so you can see where it shows up. Let me wait. So when you guys we're gonna get to quadratics and polynomials and all that, you're gonna have to find solutions. Sometimes you need a quadratic formula. And sometimes your solutions are real numbers, sometimes they're gonna be complex numbers. Okay, and so I need you to see when that will show up. So let's simplify. And let's simplify, I'll just write that. Okay, you're solving some quadratic equation and you use the quadratic formula, whatever that is. But for now, let's just see. I gotta simplify something that looks like this. 8 minus 8 squared minus 4 times 2 times 10 over 4. Okay. Let's see, I'll start you guys off, but then I'll have you guys continue, okay? So we got 8. PEMDAS, the P parentheses, you can also use it for the square root symbol. So you want to do what's inside the square root symbol first. So let's see what's inside the square root symbol. What do I have to do first?
Square root.
Before I square root, I got to simplify what's inside. So what do I do first?
2 times 10.
I can do the 2 times 10, which is 20 times 4, 80. And then this will give me 64. Actually, let's just do it together because it's I want to point out some things here. Okay, so 8 times 8 is 64, and 4 times 2 times 10 give me 80. So now I have to subtract it. What's 64 minus 80?
Wait, why did the 4 become the 2?
Shit.
Okay.
Is it? I did it.
Sweet.
Otherwise, that I was yeah. Okay, so let's see. Thank you. So what's help me out here? 64 minus 80 is negative 16. Okay. So you get that 16. This negative and this negative don't cancel each other off because this negative is outside the square root. So you got to deal with it later. But you see how you have a negative inside the square root? That's telling you imaginary show. But you got to know how to write it. So let's see. Let me move this up here. So I have 8 minus. Work that out real quick. How would you write negative 16 as an imaginary? Practice doing what we did here real quick. Oh shit, I'm out of time. No.
5, right?
Yeah, that would be the square root of 16 times the square root of negative 1. Square root of 16,
So
4i over 4. Okay. See how both of these things are over the same denominator? You can split them up into 2 fractions, but just make sure they have the same denominator. So I would write this as 8 over the same denominator minus 4i over the same denominator. Because notice if I went this way,
2i.
yeah, by doing that, this becomes 2 minus I, correct. Okay, weird, right? So this expression, when you put in real numbers, becomes in a complex number with all these operations. Sorry, guys, we stayed 3 minutes over. I apologize for that. Blame whoever signed. I'm gonna blame them punks. That was hello. Not good. That was in the recording crap.